Hello class, today we'll learn about subgraph and tree. So what is a subgraph? It's very simple. A subgraph is a part of the original graph, and it can also be a whole graph from the original. Yeah, and it follows only one rule, that is the subgraph must be without changing the original position of vertices and edges. Yeah, the subgraph must be the vertices and the edges must be in original position. And we can also say that a subgraph is a subset, yeah, is a subset to a original graph. If the subgraph is F, then F is a subset to the original graph. Yeah. So let's see example 9, and we'll see whether all these 5 example, is it a subgraph from the original one? This is the original one, yeah. Okay, so number 1, is it a subgraph? Okay, if you see, all the vertices is the same, yeah, vertices, and also the edges all the same, yeah, it doesn't change. So this is a subgraph. What about number 2? This one. Okay, this one you can see AC and BE. Yeah, AC, AAC and BE. It's a subgraph from the original. But what happened is there is a loop here. The wrong position of the loop should be in A, but it is in B. So this is not a subgraph. This one, number 3. Okay, everything is okay, but here EF, you don't have EF here, so this is not a subgraph. And then number 4, this one AC, you can see here AC and then DE. Even though this is separate, it's not connected. You can see that there is not connected, but it is a subgraph. Yeah, this is a subgraph because the vertices and the edges all still with the original, yeah, original graph. What about this one? It's upside down. Yeah, supposed to be like this one, but it is upside down. Still the same, as long as the vertices all are the same as the original graph. Yeah, so very simple for subgraph. It's very easy. So we go for the second one, tree. What is a tree? Yeah, what is a tree? Okay, it is a subgraph. Yeah, it is a subgraph, and you have to follow 3 simple rules, yeah, for that graph to become a tree. Okay, the first one is it is a simple graph with no loops and no multiple edges. No loops, no multiple edges, then it is a tree. Okay, and then for the second one, all vertices are connected, and this is very important. All vertices are connected, no isolated vertex. Remember that. And each pair of vertices is connected by only one edge. What does it mean? What does it mean by only one edge, connected by only one edge. Okay, let's say example, let's say A and B. This is a pair of vertices and it is connected by only one edge. Yeah, the edge is named A, B. Okay, so this is a simple tree lah. If you put one here, C, yeah, this is also a tree. Why? Because no loops, no multiple edges, and then all vertices are connected. You can see here, vertices, 3 vertices, it's all connected. But what happen if you put another edge here? You connect here. What will happen? Okay, this will break the rule number 2 for a pair of vertices is connected by only one edge. You see, AB is now connected with more than one edge because A connect to B, AB, right? But with this graph, it become A to C to B. It's connected with more than one edges, this edge and this edge. So this one is not a tree. Yeah, remember a tree here, it's all connected, the vertices, but it's the branch, if the tree, the branch never ever connect like this. Do you see any tree that the branch will connect like this permanently? No, never. The branch will separately grow. Yeah. So remember, rule number 2 is very important. Okay, for number 3, number of edges equal number of vertices minus 1. It is a tree when it follow this formula. What does it mean? Okay, let's say you have 4 vertices. Yeah, 4 vertices, and then so your vertices is 4, the number. So and the number of edge will be 4 minus 1. So 3. So let's check whether it's correct or not. This is a tree. Okay. And does it follow the rules here? Let us check. The vertices, how many? You can see 4. And the number of edges, how many? 1, 2, 3. So this is 3. So it follows the rules. Yeah. But what happen if, let's say, I put one edge here? Is this a tree? Is this a tree? No. Why? Why it's not a tree? Because the number of the vertices is 4. The number of edge is also 4. So this does not follow rule number 3. So this is not a tree. So remember, even though all the vertices connected, but this is not a tree because the same as this one. Yeah. In other words, you cannot have one cycle here. Yeah, this is not a tree. Okay. So please remember all the 3 rules. Okay, let us see example 10. Determine whether each of the following graph is a tree. Justify your answer. Okay, let's see. Here, the first thing you do is you count the how many vertices. This is, you have 7 vertices, and then the number of edges 1, 2, 3, 4, 5. So this is already does not follow rule number 3. Yeah, the number of vertices should be 6 because 7 minus 1. Okay, and then one more thing is it is not a tree because there is an edge not connected. You see which one? This one. Yeah, this one is not connected. Okay, next. What about this? This one, it follows the rules. Yeah, number of vertices 1 2 3 4 5 6 and number of edges is 5. Okay, but then the problem is isolated vertex. Yeah, not connected. And then here there is a break the rule number 2, more than one edges. Yeah, so this is not, this one also not. Yeah, and then for this one, of course, this is already wrong, and then there is a loop. There is a loop, so cannot be a tree. What about this one? This one already also wrong, and then this one connected more than connected in various way. Yeah, this one break rule number 2. For this one, okay, 5 vertices and number of edges is 4. This is okay, and each pair of vertices is connected by one edge. You can see here only by one edge and all connected. This one also okay, and then each pair of vertices is connected by only one edge. So that's it for to determine that it is a tree. Yeah. What about example 11? Draw a tree from the following information. So 6 vertices and the edge is 5. So first thing you do is very easy, very simple. You just draw the 6 vertices, maybe where you can put here, and then you just connect. Yeah, 1 2 3 4 5. So this is already a tree. Yeah, and then what about 4 edges? 4 edges. 4 edges. You want to know the how many vertices? So you use back the formula. Number of edges is number of vertices minus 1. So if this edge is 4, that means vertices must be 5. So you write 5 4. So you start with 5 vertices. 1 2 3 4 5, and then you can just connect here, connect here, connect here, connect here. Yeah, so you have 1 2 3 4 edges with 5 vertices. So that's it. Yeah. Let's see example 12. Draw 2 trees based on the graph given below. Yeah, so as you can see, the graph here is not a tree. Why? Because the vertices is how many? 5, and then the edges is 1 2 3 4 5 6. So this is not right. Yeah, to make it a tree, what you should do, if vertices is 5, the edges must be 5 minus 1 must be 4. So from 6 edges, you want to make it 4 edges. What do you do? From the original graph here, you minus 2. You have to take out 2 edges, right? So which edge you want to take out? Okay, maybe I'll take out this one and also this one. So you will have it like this. 1, 2, 3. Sorry. Okay, so this is 3. Another one, if you take out this and this one, what happened? You will have here, and also this one. So you still have, you follow the rules here. 5 vertices and 4 edges. 1, 2, 3, 4. This one also same. Yeah, 1, 2, 3, 4. So okay, yeah. Okay, finally we go to the last part, example 13. The following diagram shows undirected weighted graph. Yeah, the question is draw a tree with a minimum total weight. Okay, this is not a tree. We want to draw a tree with a minimum. Remember, minimum total weight. Here is the weight. All here you can see the weight. So first of all, we want to draw a tree. We have to use the rules. The very easy one is the number of vertices. How many? 1, 2, 3, 4, 5, 6. So number of edges should be 6 minus 1, that is 5. But what happened here? This undirected weighted graph, you have how many edges? You have how many? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10. So you have to make it only 5 edges. That means you have to take away how many? 5 edges. Have to take out 5 edges to make it 5 edges here, to follow the formula. So class, which edge you want to take out? Okay, remember we have 5 edges to take out. So because we want to draw a tree with minimum total weight, so we remove the one with high number of weight. So you can see here, maybe we can take out 14, 15, 13, 3 edges already, and then the rest we will hold first. We go one by one. Okay, let's say you start from A. Okay, start from A. You can you have 2 choices. You can move to 10 or take 7. So let's say 7 is less than 10, so I take 7. So we go move to 7, take 7, and then when we reach here, you have 11 or 9. So maybe I choose 9. I choose 9, and then after that I can choose 5 or 7. If I choose 5, here is already dead end, because I don't want this one no more. 14, 13, and 15 you don't want, so you stop here. Cannot. So I have to choose 7. I have to choose 7, and then from 7 here, 15, I don't want 15, it's a big number, so I choose 8. I choose 8, and then 10 and 13, I I cannot go to 10 because it will make a complete circle. So this is not a 3. So I have to choose 13. So 13. You have 5 edges here. That means, and you total up everything, you will get here 44. Okay. Now we try another root. Yeah, we try another root. Let's say we use a red color here. Okay. Okay, we start again from A here. Okay, we move 7. Move 7, and then now I choose it. I try to choose 11. Yeah, I go here 11, and then I can go here 5. Wait, 7, 11, 5, and then I go here 7 again, and then 8. 8. So if you total up here, you'll get 38. Yeah. Okay. So, are you satisfied? Maybe there's other root that will be minimum total wage. We try another one. Let's say green one. Okay, let's say this time we choose 10. 10, yeah? 10, and then we go 8, and then we go 7, and then 5, and then 11. Total up. This one you get 41. Okay, so now class, this have the minimum total wage, so we choose this root. Yeah, we choose this root. So next is we have to draw the tree. Yeah. Okay, now let's draw. You just follow from A. Yeah. So here 7, and then 11. 5, C, 7 here, and then 8. So you label A, E, D, C, and B. So this is the tree, yeah, with minimum weight. So you are done with the problem. So I hope you understand, and if you don't understand, you can always ask me. Yeah. So that's all, class. Bye for now.